Hey guys. Um, Today I'm going to be talking to you guys about the Pythagorean theorem. You guys may have learned it or may have heard of it as Pythagoras' theorem. Um, Pythagorean, Pythagoras's, it's the same thing. Uh, they're what we call synonymous. They're synonyms. They mean the same thing. It's a quick little ELA lesson, I guess. Um, but they're just two different ways of saying the theorem that was discovered or developed by this guy called Pythagoras in ancient Greece, I believe, in ancient Greek. But basically, all it says is that it's a way to relate the side lengths of a right triangle. A right triangle being a triangle with one angle being 90 degrees, and that's what this little square means. It means that angle is 90 degrees. So Pythagorean theorem, really what it is that it just says a squared plus b squared equals c squared. All right. And in the problems I show you guys, we're going to prove that this statement, a squared plus b squared equals c squared, is true. Okay. So this really, this, hold on. Yeah. This thing that I just put a box around, that is Pythagorean theorem. The Pythagorean theorem. That's really all it is. It's actually looks super basic when you actually look at it written out like that. And hopefully with these couple examples, it's not going to be so. It might not seem as daunting as it is for a lot of you guys. Okay. So, let's do a really classic example. All right. Example. All right. So let's start off with a right triangle. My drawing ability is not perfect, but we're doing the best we can. Okay. So a really classic example of a right triangle is a triangle with one side is 3, one side is 4, and one side is 5. All right. If you're getting confused by these numbers, like what these numbers are, you think about it. Let's say you just have like a triangle piece of wood, and it's a right triangle. One angle is 90 degrees. One side is 3 inches, one side is 4 inches, and the other side, the diagonal, the hypotenuse, is 5 inches. All right, that's really all it is. Like if you had a rectangle made of wood or metal or something in your hand, you could measure all the sides, and you'd see like if one side's 3, one side is 4, then the diagonal, the hypotenuse, has to be 5. All right. Otherwise, it's not a perfect right triangle, which is interesting. But really, all you can do is I like all you can do is not worry about the units right now and just think about the number itself, because units get a little tricky. Anyway, so if you have this right triangle by Pythagorean theorem, a squared plus b squared is c squared, you should be able to write a statement that relates all of these side lengths together. So let's say like 3 is the a side, so 3 squared, and then 4 is the b, so 4 squared equals 5 squared. Yeah, you're gonna learn actually very quickly that you have to write it like this. You can't write it, like 3 squared plus 5 squared equals 4 squared. That does not work. And that's because the whole point of Pythagorean theorem is that the side lengths, the two shorter side lengths, so the a and the b in a right triangle, squared added together must equal the square of the hypotenuse. This c value is always going to be the hypotenuse of the triangle, right? So the hypotenuse, meaning the longest side, the side across from the 90 degrees, et cetera, et cetera. There's a bunch of different ways you can specify or define the hypotenuse of a triangle. I digress. All right. So if we do this out, we know, hold on. Yeah. We know that Pythagorean theorem means that this must be true. So let's check it, okay? So 3 squared is the same as 3 times 3, which is 9, plus 4 squared is the same as 4 times 4, which is 16. All right? And then 5 squared is 5 times 5, which is 25. All right? And now if you just do 9 plus 16, that equals 25. All right? 25 equals 25. All right? So we know that this is true because, I mean, obviously 25 equals 25. So really all this says is, this proves Pythagorean theorem holds up, when you have side lengths that add up. Let's see, let's do another example, because, we want to make sure this isn't just, a fluke. Like this isn't just for like a 3, 4, 5. So let's do a 9, 12, 15. I think it is. Hold on. Yeah. Let's do another example. There. I just like having a dot there. I don't know. Let's do a 9, 12, 16. All right. So this side is 9, 15, not 16. I think I said 16 a second ago. 9, 12, 15. All right. So we have 9 squared plus 12 squared equals 15 squared. All right. Let's make sure this is true. All right. So 9 times 9 is 81 plus 12 times 12 is 144. I know in the 12s, 15 range, like in the teens, doing the square numbers is kind of hard. I just have most of the perfect squares memorized. That's just something you learn as you get older. They stick in your brain a little bit better, right? And then 15 times 15 is 225. And you can fact check me. You can use your calculator. You can just type in 9 times 9, 12 times 12, 15 times 15. You're going to get these values, right? And then what you do is you add these two together. So 81, let's do the ones place first. So 1 plus 4 is 5. The 8 plus, this is an 8, yes. Now 8 plus 4 is 12. So the 2 goes here. And then the extra 1 from the 12 goes there. So 225 equals 225. That's right. So this, just from a couple examples, is giving us some pretty strong evidence that Pythagorean theorem holds up. It is true. And honestly, I'm going to, I think, give you guys one more. This is actually isn't going to be a problem. This is going to be um, um, all right. So I've already showed you guys, like the a squared plus b squared equals c squared, and I've just showed you through examples why like these numbers work out. If you have certain numbers and the sides work out, they end up equaling each other. But really, I'm going to show you guys maybe a little bit more conceptually, like really seeing it, why it actually works. All right. So let's say we have a right triangle. Or hold on, here's what we're going to do. let's say we have a right triangle or a square, right? Let's say we have a square, right? So of side length b, right? And let's say we have another square over here of side length a, right? Bear with me, right? So these are all the same. These those dashed lines are just kind of like notation. They show that all the sides that have the same number of dashes through them, they're equal in length. And then let's say we have side C with a box. This one's a little sketchy, but I'm doing the best I can. All right. And then this is side C, all right? And then this is a square again. All right. And let's say it's a right angle right here. All right. So this part in the center is our triangle. And then, we have side length A, B, and C. And, for each side length, there's kind of like a square of the side lengths that go with it. All right. And really, Pythagorean theorem is another way of saying that the area of this square, the area of, I'm going to use the green now, area of this square plus the area of this square is equal to the area of that square. All right. So let's go back to one of the examples I showed you a second ago, where, yeah, I'm just going to use, I'm going to, how about this? I'm going to, oh no, that's not going to work. Okay. So I'm going to use the multiple colors again. Example. All right. So let's say you have a triangle and one side, this is going to be like the B side, one side is 4. All right. And you have the square. Hold on, that's really bad. One side is 4. All right. And then you have a square that is kind of associated with that side. All right. And all those are the same length around. And then you have side length. Was it red on the bottom? Yeah. Then you have a side that's 3. And you have a square that goes with it, the right angle. And then you have side C, which is 5. And that has a square that goes with it. All right. So now we have our different squares. And Pythagorean theorem, like I said, is just saying that, like this area and this area added together equal this area. All right. So let's find the area of the 3 by 3 square. So area, as I'm sure you know, or have been taught, but if you don't remember, maybe the area of a square is just, or the area of a rectangle, even a little bit more general than a square, is just the side lengths multiplied by each other. But because a square, the side lengths are equal to each other, you can just say, instead of saying like 3 times 3, you can just say 3 squared. All right. So the area is 9. All right. In this one, the area is 4 times 4, another side length. That makes it 16. And then as I'm sure you can see where I'm going with this, the area of this is 5 times 5, the two side lengths, and that's 25. All right. And then all you do is the area of this 9 plus the area of this 16 equals 25, which is the area of this square. All right. So that's just like a different way to visualize it. It's kind of a way I never saw this kind of diagram shown when I was in school, when I was learning this. But this is something I've actually seen in recent years. People explaining what Pythagorean theorem is. And I think it's actually just a much better way to visualize than just being told like, hey, a squared plus b squared equals c squared. This actually puts it in perspective. It's like, oh, the area of this square with the side lengths and the area of this square equals the area of the square, right? So let's add a page and do problem 1. I'm going to leave the little green dot there. I like it. All right, problem 1. And let's go to IXL and just see whatever problem comes up, all right? What was the length of the hypotenuse, C? So you have 9, 12, 15. Oh, well, we already did this example, actually. But so, you have the 9, the 12, and the hypotenuse. So C. So C squared equals the other two sides. So the 9 times 12, or 9 times 12, geez. 9 squared plus 12 squared plus 12 squared, right? So as I showed you in the intro, this actually ends up being 225 equals c squared. Now we're not done, obviously, because if it's asking you the question, it's asking you what c is, not c squared. So what you do is you actually take the square root of each side. My phone is ringing, but I can't talk at the moment. And so square root of 225, as again, I'm sure you guys have figured it out, is 15 equals c. Sometimes you'll see people say that when you take a square root, you have to consider that it's like positive, negative, because negative 15 squared is the same as 15 squared. But for a triangle, the side lengths are measuring distance, and you never really measure distance in negatives. So in this case, it's always going to be the positive value. It's always going to be 15, or just the square root, the positive square root. All right. So let's think of another example. All right. Add page. This one I'm going to show you is not going to be as perfect numbers. All right. But I promise you guys can do this. All right. So what we're going to do is we're going to have a triangle, a right triangle, and the side is, let's say, 5 and 10. All right. So this is a right triangle. This side's 5, this side's 10. What is the hypotenuse? C. All right. So let's set it up just like we did problem 1. We have 10 squared plus 5 squared equals c squared. All right. So now we have 10 squared is 100. 5 squared is, we've already done this one, 25, and it equals c squared. So 100 plus 25 ends up being 125. And then, just like I said before, we're not done once we get c squared. We need to get c. So c equals square root 125. All right. Now, as I gather you're probably realizing right about now, 125 isn't a really easy square root to take. We know that 11 squared is 121, and 12 squared is 144. So we have to know actually that 125 isn't a perfect square root of some number. All right. So what you can do from here is you can try and simplify it, but without using a calculator, you're not going to get rid of this square root entirely. All right. So let's just think 125. That looks like it's divisible by 5. So let's do that. 125 is divisible by 5, and you end up getting c is equal to square root. 125 is actually 5 times 25. All right. And now what we see here actually is that 25 is a perfect square. 25 is just 5 squared. So what you can actually do is you can do the square root of the 25 times the square root of 5, you know? If you haven't learned that before, when you have a square root like that, you can multiply it like this. You can separate them. And obviously, if you just take the square root of 25, you get 5. So writing this all out, you end up with simplified 5 square root 5. And that's what c equals, right? And if you use your calculator, which I'm going to do right now, square root of 5 times 5, that is this little, I know all my equal signs are a little squiggly, but this one's meant to be like extra squiggly. This one is about 11.18. And I just used my calculator for that. I didn't know that off the top of my head. I knew it had to be greater than 11. Like what I said earlier, this is in between 11 squared and 12 squared. But we can check, does this value make sense, 11.18? It does, because it's greater than either of the side lengths individually, and the hypotenuse always has to be the longest side. All right. Let's do one more example. And this one is going to be a little bit different. All right. I'm going to shake it up on you guys a little bit. But you know, I have faith that you guys can figure it out. All right. Let's say you have a right triangle. And let's make the hypotenuse 9. Let's make this a side value 6. And we're gonna try and find side B. Or actually, that's a terrible idea. 6 and B looks. We'll make it 5. And this is side B. Right? So if you notice, rather than trying to find the hypotenuse this time, we actually have to find one of the shorter side lengths. But the setup isn't that different. So we know 5 squared plus b squared has to equal 9 squared. All right? So 25 plus b squared equals 81. All right? And you subtract 25 from both sides, and you get b squared equals 54. Is that what it is? Or 56. Oh my word. Right? 81 minus 25, 56. Yeah. I can do math. It's fine. I was just trying to do it in my head. All right. Yeah. B squared equals 56. So now all you do, again, you're going to take the square root of both sides. So b is equal to square root of 56. And again, that isn't a perfect square. You know, 7 squared is 49, 8 squared is 64. So this is somewhere in between 7 and 8. But without using our calculator, we can simplify it a little bit. So 56, I just know this one off the top of my head. That's divisible by 7, which is a prime number. All right, so that's actually the same as square root of 7 times 8. All right, and now, again, we still don't really see any numbers that are perfect squares, but we see 8. And 8 is always kind of a nice number to see in square roots because where there's an 8, there's always a 4. All right, so we see the square root of 7 times, now 8 divided by 4 is 2. All right, and now we see that we have a 4. We do have a perfect square. So we take that out, and square root of 4 is 2 times, and then we still have the 7 and the 2. We can't simplify that anymore. So I'm just going to multiply those back together. You have square root of 14. All right. And now, if you do that, square root of 14 times 2 is, you end up getting 7.48 as the side length, which makes sense because, again, we're not finding the hypotenuse. So it's okay that one of the sides was longer than what we found because we were solving for B, which is not the hypotenuse, not the longest side. Right? Basically, that is how you go about solving a problem using Pythagorean theorem. Just remember, this is the formula you use. C squared is the hypotenuse, the longest side, the diagonal. I always remember it's just the one that's opposite from the right angle, the little square here. And then A and B are just the other two sides. This other description, you should remember, you can think of it as areas of squares using the side lengths of each of the sides of the triangle. And then these couple practice problems, this one, it doesn't always have to be perfect numbers. That's just simplifying what we call a radical, a number under a square root. And then this one, rather than solve, you don't always have to solve for the hypotenuse. Sometimes you have to kind of go backwards and solve for a side length. All right. So that'll be it for today, guys. I hope this was helpful. I hope this, made this whole concept make a little bit better sense. And good luck with your homework, guys. All right. Take care.